Lesson 64 covers similar triangles. Similar triangles are triangles that have the same shape, but they don't necessarily have the same size. What you need to know here is this little squiggly line here is a symbol used to denote that two triangles are similar. So the vertices of the similar triangles are written in order to show the corresponding parts of the triangle. If you look in the key concept, it shows you that triangle ABC is similar to DEF, and they go in that same order. Now when you do the corresponding piece, this is saying AB here. There's AB. AB corresponds with DE. Notice it's going in that same pattern. It's not corresponding to ED, it's corresponding to DE. A corresponds with D, B is corresponding with E. In example 1, you need to determine if the two triangles are similar by justifying your answer. Well, if you can think about this, these little symbols are showing you that these angles are the same measure. So if this here is 98, well, the other ones would have the same measure. We know that the interior degrees of a triangle is 180 degrees. So if we take 180 subtracted by 98, that would give us the remaining degrees in that triangle, which would be 82. Two angles, we divide it by 2, we get 41 degrees here. So both of these angles would be considered 41 degrees. So these would be, in this case, similar triangles. If you look at that smaller triangle here, here's the unknown measure. Well, these little arrows here are indicating those are the same lines. So if you could actually figure this flipping around here, always helps if you take a piece of paper and trace, but when I flip this around, you would notice that these would line up with one another down here. Your 41 degrees, 41, 41, 41, and then your 98 degrees for side C. So these would be similar angles, doing the math here, that they both come out to be at 41 degrees. So I would state that these two are similar with the notation stating that triangle PRQ, here's PRQ, is similar to, now remember, take this one here, flipping it around, here's P needs to line up with B, which it does, listed first, BRC. Our next example, instead of using angles interior, they're giving you measurements to determine if things are corresponding triangles or similar triangles. What I like to do is go ahead and break this down into two triangles, so draw two separate sketches. To determine if these are similar triangles, what you want to do is break it down into two similar triangles. I have all the measurements there. What you need to know about similar triangles, everything will be proportional to one another. So ET in triangle 1 would correspond with ED in triangle 2. I'm going to go ahead and put the measurements down, and we can figure out the measurement of ET. How do we do that? Well, 36 is TD. We know that the whole measurement is 66. So from T to E, this has to be 30. So we'd have 30 over 66. I'm going to go ahead and list off the other ones that we have, of the other side lengths, and I'm going to stay consistent. Triangle 1, triangle 2. So here's another measurement. TS, which is 20, will correspond with DC, which is 44. DC, 44. And we only have one side length left. That being ES, which is 25. And that would correspond with 55 for EC. As mentioned before, all of these would reduce to the same amount because these are or similar triangles. So when I reduce this fraction, I get 5/11ths, 5/11ths, 5/11ths. Looking at all of them, they are all proportional to one another since they reduce down to that same fraction. So these two triangles would be considered similar triangles. So I would go ahead and write that notation out, stating that triangle ETS is similar to triangle EDC. And proof is what we have down below. Similar triangles, you also can find missing side lengths by setting up proportions. So I normally start out by labeling my two triangles, triangle 1 and triangle 2. Next I want to match up the sides, so I usually trace one of the triangles. I've traced one of the triangles. Now it's easy to go ahead and line up what matches with what when I get that rotation. So I bring it down over here. Now I can see what corresponds with what. It makes things easier. So go ahead and set up your proportions here. Triangle 1 will go on the top, triangle 2 on the bottom. We are trying to find out the missing side length there. That is a question mark. So there's my question mark. That is part of triangle 2. So I'm going to go ahead and throw that down below. That's the unknown. Well, the unknown is going to line up with 24 on triangle 1. So those correspond with one another. 36 in triangle 1 will correspond with 9. It's a 9. Remember, it's upside down here. Will correspond with a 9 in triangle 2. So I'm going to go ahead and drop 9 down. Well, to solve for x, you simply cross multiply and divide. So I cross multiply 24 times 9, divide it by 36, and we find out that x equals 6, or the unknown is 6 units in this case. Example 4, same scenario. We need to figure out the unknown side length, so we need to go ahead and break this down into two triangles here. So here's my two triangles sketch. Go ahead and label one, triangle 1 and triangle 2. Next, we'll set up the proportions. Triangle 1 and triangle 2. The unknown is in triangle 1. So here's my unknown. That'll be represented by x. X will correspond with 5 in triangle 2. Now I just need to use another measure. In triangle 1, I know that 12 is the top. That'll correspond with 4 in triangle 2. Again, we go ahead and we cross multiply, and then we'll divide by 4, and we find out our value for x is going to be 15. Same scenario in example 5. The only thing that they throw at you is an algebraic expression. No big deal here. Same thing. We want to go ahead and call one triangle 1 and triangle 2, and we'll set up that proportion to cross multiply and divide. Make sure that corresponding things line up with one another. Notice L is right here. Those are the corresponding ones. So if you need to, go ahead and rotate things if you're able to visualize without doing it. Go ahead and move on. Personally, I like tracing things to make sure things line up, and then I can go ahead and spin this baby around or rotate, and I slide it up, and I know that my corresponding things are in check. So I know that 42 in triangle 1 will correspond with 12 in triangle 2. I know that in triangle 1 we have 10x minus 3, where we're trying to solve x. 10x minus 3 will correspond with 22 in triangle 2. So now you go ahead and you cross multiply and divide again. When you cross multiply, you have 42 times 22, which is giving you 924, equals. Well, when you cross multiply here, you're taking 12 into a binomial here. So you need to actually go ahead and FOIL this. 120x minus 36. Now you're back to solving equations. Get x by itself. Adding 36 to both sides, giving us 960 equals 120x. Getting x alone by dividing by 120. Finding out that x is 8. And note in this problem, if you look back at that set of instructions, it says solve for x. So we've solved for x. X is 8. It doesn't say find this side length. If we had to find this side length, we would know how to do that by substituting 8 in for x. Example 6, why don't you go ahead and give it a shot, see how you do. Come up with your proportions and cross multiply, divide, figure out what our value for x is. Set up corresponding sides, there we go. Cross multiply and divide. Given us our equation, get x alone. So subtract 66, the next step, go ahead and divide by 33. Finding out that x is equivalent to 4. If you wanted to double check to see if your answer is correct, well, simply substitute your value of 4 in for x up here, giving us 18 for that value for that side length. Now if you think about it, your 6 corresponds with 18, and your 11 corresponds with 33, so 11 over 33. If you reduced both of these fractions, they would both reduce to 1/3, showing you that things are proportional, and it does check out, so 4 would be the correct answer. This will conclude lesson 64.